Okay, so the next video is going to be about box plots on page 9. We'll cover 9 and 10. Actually, we'll get that one question on 11 probably in this one, and we'll call it good. But it's a little bit off the schedule because box plots are no, box plots are for Friday. No, I guess we're right on. Spreads a different spread. It's standard deviations later. I'm mumbling now. I'm sorry. Rambling, not mumbling. Of course, mumbling too if you talk to my wife. But when are box plots useful? So we have to know what a box plot is. Okay, a box plot is going to be a useful tool to compare groups. Okay, that's where we're going to find. I can compare freshmen, sophomore, junior, seniors by putting their data into a box plot and then compare the box plots, and then that allows me to be able to look at the distinct features and compare them. Again, this is for large sets of data. We can't see individual pieces. Okay, is again the con. Now the box plot is based upon the 5-number summary. So the 5-number summary is this. It is the minimum. It is the quartile 1. It is going, which is a abbreviated Q1. A big stretch there. Median, quartile 3, which is Q3, and then we have a maximum. So those are going to be the numbers that we're going to base that 5-number summary is what we're going to base that off of. Okay, so basically what happens is this: if we could take our data and we put it on a number line like this, and we had just I don't know how many points I'm going to make here, but there's my data. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points. Perfect. Okay. So if I take 11, I add 1 to that, that's 12. So that means that the 6th point, 1, 2, 3, 4, 5, 6, the 6th point is the median. Okay. Because that means I have 5 pieces below and I have 5 pieces above. And then what we're going to do is we're going to find the midpoint. I'm going to take it's like I folded a piece of paper in half, and then I'm going to fold it in half again. So 1, 2, 3, 4, 5. The 3rd piece is going to split the lower half in half, and because I have 2 below and I have 2 above. So since I took and 1, 2, 3, so there's going to be the other fold up there. So because I took a lower half and I folded it in half, there's going to be quartile 1. And because I took the upper half and I folded it in half, there's going to be quartile 3. Okay, so all I'm doing is I'm taking my data and I'm splitting it up into 4 equal parts, and we're going to make a graph based upon those 4 equal parts. Okay, and so to define what the lower quartile is, it's going to be the midpoint of the lower half. And quartile 3 is going to be the midpoint of the upper half. The interquartile range is going to be resistant to variability. So we got to talk about what the interquartile range is. So we have to pay attention. There's the interquartile range. Its abbreviation is IQR. It is going to be calculated by taking quartile 3 minus quartile 1. So what we have is we have the inner quartiles. Okay, or we have, what's going to happen here is we're going to then make a box around from quartile 1 to quartile 3 is a box, and then my whiskers are going to go down to the minimum and up to the maximum, and that's what's going to make my box plot. Okay, we'll actually make a box plot here in a second. Note that in statistics, resistant means not affected by outliers. So the one measure of variability that we have is going to be called the interquartile range, because if I have this set of data, and let's say we threw Fancy Town, Shabby Town in here, and we've got the $2 million house over here, that's not going to affect this house turned into this house. Well, because I'm splitting it in half by position, these are not going to change. So therefore, this is going to be what's considered resistant to outliers because it's by position only. And so what if that point, my largest value is here or my largest value is here? It's irrelevant. Okay, so that's the part that we have to say that it's resistant to outliers. Now again, that interquartile range, what we circled here, remember that 25% of my data is here, another 25% of my data is here, another, because I split it into quartiles, 25% of my data is going to lie in each spot. So if we talk about the interpretation of the interquartile range, the interquartile range is my box, what portion of data lies within my box. If we add those together, that's 50%. So this is going to be the middle 50% of the data. Okay. All right. I've probably overtalked that, but we are ready to move on. Example 8. 15 students with part-time jobs were randomly selected, and the number of hours worked last week was recorded. Okay. Well, congratulations. I don't know what it wants us to do here. So, excuse me. So I guess we'll make a box plot out of this and go from there. Okay. We can start out with 0. Actually, here what we're doing is this section is here to let us figure out what those outliers are. So now we're going to have a definition of what an outlier is. So just because I want to, we're going to drop that in there. So I got my calculator over here, and I'm going to drop that data into my calculator really fast, just so we can have our calculator calculate the stuff for us. There's no sense in us recreating the wheel. I would have paused the video, but that I don't think it was too long. So anyway, so let's go back out to my calculator again. So my calculator, that box plot is created by the 5-number summary. Okay. So I'm going to go ahead and do a stat. We're going to go over to calculate. I'm going to choose option 1. I believe that's stored in L5 then. Okay. So there is all the things that I need as far as marking this box plot. Okay. So I know that if I scroll down here, I'm wanting my 5-number summary at the bottom. Get that so it all shows. Okay. Looks like I go all the way from 2 up to 25. So here's 2. Here's 4, 6. Okay. So we're gonna make this box plot. Okay, and I struggle a little bit here in the fact that this data contains an outlier. So what we should be patient with the way we do this. We'll go ahead and plot it as it would without an outlier, but then we got to go back and make sure we can figure this out. Okay, so I know that my minimum value is 2, so I'm going to put it down at 2. Quartile 1 is located at 8, so we put the left side of the box there. My median is at 10, so we're going to mark the median in the middle there. And the quartile 3 is 14, so we're going to do a line there. And so then we'll connect the box there, and I could draw that whisker in there. And then it looks like my max is going to be 25. So I can see that right now my max appears to be a long ways away. Okay, so there is a possibility this could be an outlier. So now we need to figure out what that definition of an outlier is. Okay, and here's what we have. An observation is an outlier if it is more than 1.5 interquartile ranges away from the closest end of the box, less than the quarter or less than the lower quartile minus 1.5 more than the upper quartile. Sorry, that's just less. I'm not sure what that said. Less than the lower quartile minus 1.5 or more than the upper quartiles. Now, I don't know why tonight that is not making much sense to me, but here's what it is. We have an interquartile range. If I actually measure my interquartile range has a distance of 6. Okay, from 8 to 14, that's a distance of 6. We're going to do 1.5 times my interquartile range. Okay, so we start at quartile 1. So my lower boundary is found by starting at quartile 1 and subtracting away 1.5 interquartile ranges. My upper boundary is found by taking quartile 3 and adding on 1.5 interquartile ranges. So that is how we're going to determine. So, if I don't need a ruler here. So this is my box is 6 long. I'm going to take 6 times 1.5. Well, half of 6 is 3. 3 plus 6 is 9. So from 14, I'm going to go 9 units up. So 14 and 9 give me 23. So there's going to be my boundary line. If I have a point that lies outside that boundary, that means it's going to be an outlier. So therefore, 25 is going to be an outlier. Now the problem is I need to identify that. Typically we star outliers. But now I need to stop my whisker somewhere else. I have to find my next largest piece of data. Okay? And it looks like 19 is going to be it. So here at 19, we have that, and now my width. So this is my, so if I, again, this is where we'd, ahead of time, we'd pay attention to that outlier. Okay? If we tried to go the other way, so we decided that that distance above the third quartile or below the first quartile is 9. So we're going to go with 8 minus 9, which is a -1. So obviously there's my lower fence. I can't work a negative number of hours. So there's no way we're going to have an outlier on the lower range. So again, this is going to be another one that it's a piece of it's data that could only be skewed to the right because I can't work a negative number of hours. Okay. So the whiskers and there's the noted, they extend to the last value that is none. So actually, I did a bad job with this. Let's go ahead and do the formula thing because that's what your question's going to look like. They're going to ask you to, I didn't even notice that was still not even centered. They're going to ask you to show the calculation of the fence for an outlier. So quartile 3 was 14 plus 1.5 times my interquartile range of 6. And that ended up being 23. So it's 8 minus 1.5 times 6. And again, 6 was found by taking 14 minus 8. Anyway, that's going to be -1. So that's why we had the outlier. We had to show, we had to prove it's an outlier. Now the thing is, if you go to your calculator, and again, our calculator can help us a lot. My calculator will make a box plot for me if I wanted to. So we go second and y equals. Again, we're going to go into plot 1, except now as we come down to the graph type, we're going to pick a box plot. Now there's 2 different box plots on here. One shows dots, one doesn't. So that means this is the one that shows the outliers. That's the one I want to select. My data is stored in list 5 and zoom and 9. So there is my box plot. And now to introduce again something else that my calculator will do. Boy, that glare is horrible. Not that that helps at all, but we could hit the trace button, and when we hit the trace button, that's into the glare. All right. Okay. Now we can see then that it tells me that my median is 10. If I arrow to the left, it's telling me that quartile 1 is 8. If I arrow to the left again, it's telling me my min is 2. So it's actually telling me my 5-number summary. Quartile 3 is 14. That largest whisker then, that value is 19. And then it's showing me that I have an outlier at 25. So my calculator will show that. Now the thing is, though, when you get to the exam, they're probably going to say, calculate the outlier from given statistics. So it's not going to be that your calculator is just going to be able to bail you out on that. We just need to be able to calculate that. All right, we're going to compare distributions again. By plotting box plots, 2 separate groups or subgroups, we can compare their distributional behaviors. Make sure you use your CSOCs in your description as well as comparative language. Okay, so again, C stands for context. We want to know what context are we talking about. This is going to be the haircut cost in dollars for males and females. Okay. So the distributions of haircut costs for males and females are, okay. Now again, looking at box plots, sometimes again we can see characteristics because if I had symmetric data, my mean and my median would be roughly in the middle. But here we can see that there's a large distance to the right here. So that means since my box is extended on the right and I have a huge right whisker, my female, okay, are skewed right for females and roughly symmetric for males. Now again, this is just a checklist thing. We talked about context. We've done the shape. O again stands for outliers. Okay. Now, oddly enough, even though this sticks way out here, I got a really long box. So therefore, my outliers, it's my data is spread out. It's just not one or two pieces out there. So really, it's neither distribution is showing an outlier. Okay. With neither distribution showing an outlier. Okay, so again, here's where my comparative language comes in. My comparative language is going to be my ER words. Okay, so we're going to talk about the typical female haircut. We're going to, and since this is skewed to the right, I have to use my median. My median was the only thing I was given, so that's kind of a a null and irrelevant, I guess. It looks like 30. So the median price of the female haircuts is about $30, which is greater than the median price of, what did we say that median price was? 18, $18 for males. We've taken care of the, we talked about the outliers, we have talked about center, and now we've got to talk about spread. Okay. The spread of the female cost is, what does that go? Well, they all got free haircuts, but the ladies go up to 150 roughly. The guys only go up to 40, 38. So the spread of the female cost is $150, which is greater than, and again, I used greater than in both of them, but that's okay. And didn't know you couldn't see what I was writing. My bad. Which is greater than the male spread of 38. And that takes care of my spread. So again, all of those pieces are going to be requirements to get a full AP answer score. Okay. All right. We'll go ahead and grab. There's a question on page 11 that we can grab, and then we'll save variance for next week. So a multiple choice example. The weights of male and female students in middle school PE classes are summarized by the block spots. We've got males and females. We have to figure out which of the following is not correct. So again, sometimes it's we have to pay attention. And AP wise, sometimes they'll flip it around and make sure you're looking for the. They're going to give you a bunch of true statements, and you have to figure out which one is wrong. Versus typically you're always looking for the true statement. So as we roll through this, let's see what we have. About 50% of the males have weights between 150 and 185. So here's 150 and here's 185. So that fell on the quartiles. So that is a true statement because that's the middle 50%. Okay. The median weight for the female students is about 121. So the median weight is going to be that line in the middle, about 121. That's true. About 25% of the female students have weights of more than 128. So 128 falls right about there, and that's going to be the right whisker, and a whisker is worth 25%. So that one's true. The median weight of the male students is about 166. So 166, there's the median. I'm going to go with that one. So process of elimination leads us to E, but the female students have more variability than the male, and that's going to be my false statement because variability is how spread out it is, and the males are more spread out than the females, so that means the females actually have less variability. All right, let's go wrap that up at the 20-minute mark. So we got one more lecture to go.